one thing I will say is one of the best reports I've read recently on this this experiment. What one guy did was he used a bit of kind of color coding to try and explain some of the stuff that was happening. He kind of color coded stresses and color coded the strains and used that to help him explain what was going on, and it worked very well. Especially when you come to explain the complex stress, I think a bit of color coding certainly does not do any harm. There's different stresses and different strains here. Definitely trying to do this without a diagram to refer to is not a good idea. I think you really need to have it represented diagrammatically to try and help you explain what's going on. But, however you try and communicate it, you've just got to make a good attempt to show your understanding. I want to read your explanation of why these gauges are doing what they're doing and get the feeling that you understand the theory. That's one of the things I'm looking for. I'm going to double the pressure now, up to 1 meganewtons per meter squared. What readings would I expect from these gauges here, roughly? Double, about 200. This one, about minus 60. This one, about plus 60. This one, about plus 120, 30. This one, I don't actually expect it to double because it's staying around 0. We might find it just kind of stays around 0. We might find it starts heading back towards 0. But basically, if we double the pressure, we should see all these strains starting to double. There is a delay, so I've got to be careful. Sometimes you think that's reading the right value, and there's a wee delay. They don't have to be bang on. I don't have to get all these things bang on 0.5 and 1 and so on. It doesn't really matter. They're a little bit different. So I'll just go with that. So I'll record that set of readings there. So it's 1.02, but that doesn't matter. And you can see about 200, about minus 60. That's about plus 70, but again, it is kind of halfway in between. In fact, it's not about halfway in between, it's almost exactly halfway in between. Pretty much bang in the centre, isn't it? 130, yeah, 130 either way. So it is right in the centre. That one's doubled pretty much. It's up to 130, and that one doesn't seem to have moved, it's just staying where it is. It is experiencing kind of tensile and compressive strain together. They're just cancelling one another out. Again, just add another half meganewton per meter squared of pressure, or thereabouts. We're going to go over that one. Just the same thing that's happening. These are now up to about 300. This one's now minus 90. As you can see, this one's just not heading anywhere. By the time I get up to 3 meganewtons per meter squared, what are we expecting? Roughly about 600. They won't quite be there, but they'll be not far off 600. This one about minus 180. We'd expect basically double where we are now. If this is 1.5, if we take up to 3, we're expecting all these numbers to double basically apart from that one, because it's not really heading anywhere at all. So again, just add another half meganewton per meter squared of pressure. Okay, so as you can see, gauges 1 and 6, again, up about 100. They're all just going up in a linear fashion, nothing too surprising. And as I've said, clearly, these strain gauges are very sensitive, so they're measuring changes in the shape of the cylinder that we are never going to see with the naked eye. The cylinder is looking no different to me. Maybe you can see a difference in it, but I certainly can. We're not talking about drastic changes. We're dealing with something that is pretty rigid material. Not as rigid as some, but it's pretty rigid. We're not going to see it dramatically changing shape.
Would there be any cases at all when the strain gauges would go up in a linear fashion, like if the cylinder was like...
Something other kind of component maybe, but the theory, the kind of thin cylinder theory tells us that basically if you double the pressure, you double the stress. And if you double the pressure, you double the stress, that means you're just going to double the strain.
So it's like kind of proportional.
It is linear. There's a linear proportionality, I think is a fancy way of saying it. snapshot that one. So then we just take up to this final pressure, particularly when you get up to these high pressures, it can be quite difficult to actually get the pressure to go up. But, so hopefully I just hit 3, but no, it's got 9. Yeah, see there's a delay. We've got to always remember about the delay.
Lag compensation.
So there we go. That's the results we're going to use to do certain things with. We'll discuss later exactly what we're going to do. Hopefully you realise some of the things we're going to do with these results, but nothing too surprising. I think once you understand what's happened with that first set of results, everything's just increasing in a linear fashion, although no, gauge 3, it's actually gone down, but the thing about gauge 3 is it's basically just stayed at 0. It's barely moved away from a value of 0. There's this particular direction in which it's lying, that direction is not being stretched or compressed because the effects of the stress, this expansion and contraction, they're kind of cancelling out. Once we've got all our results, I am going to take a snapshot of that and I am going to paste it into this lovely old version of Excel. Antique version of Excel. And I will put those results up onto Blackboard. Once I've got all the results I need there, I'm just going to open the pressure release valve, let the pressure out, and we'll get ourselves set up for the next experiment. So what I need to do is go to experiments, disconnect, and then change to the closed ends condition. It reminds me when I'm changing to the closed ends condition to wind the hand wheel out. And again, just to make it kind of to sort of, so there's no doubt, I can actually just remove this completely. I don't need to remove it completely, but just so there's no doubt, I remove that bolt completely. There's now no way that the pistons in there can transfer the force, the loading, to the framework, because I've taken that bolt out completely. The pistons, when I pressurise the cylinder down, the pistons are going to move out, push against these end caps, and those end caps are going to transmit the loading into the axial loading into the cylinder itself. So it's still going to be dealing with the hoop stress, the walls of the cylinder, but it's also now going to be dealing with axial stress at the same time. I'll leave the pressure release valve over just now. I won't do anything else with it just now. I'll zero it and all that just before we do this setup. But now we're going to, again, this is a bit trickier. We're now going to try and predict what's going to happen here. This is definitely trickier. You've got to be thinking a bit harder than for the simple stress. Okay, so let's see if I can undo. So we've now got complex stress. We're in the closed end setup. The walls of the cylinder have to take hoop stress and they have to take axial stress. So crucial thing, or a crucial thing, there's a few crucial things to bear in mind here. One of the crucial things to bear in mind here is we've got this exact relationship between the hoop stress and the axial stress. And the other kind of thing to bear in mind if you're going to predict what these gauges are going to do. So we've been told the Poisson's ratio is 1/3. We've been told this, but we've actually seen from the open end setup that that's a pretty good value for Poisson's ratio because we were kind of seeing that happening. Based on those two bits of information there, you should be able to start telling me which gauges might give positive readings, which might give negative, if any, what the gauges are going to do here. But it does require a bit of thinking. And again, we're going to try and predict some values for, if I pressurise this to 0.5 meganewton per metre squared, particularly for gauges 1 and 6, I'm going to try and make a prediction and hopefully you can follow the basis on which I'm making that prediction and then we'll see if my predicted values for 1 and 6 are any good or not, or they're miles off the mark. Again, anyone tell me, the gauge here, positive, negative, why? Any of these gauges anyone pretty confident about what it's going to be reading?
All of the positive.